and try to get through with this. So today we shall be looking at revised simplex method. We shall be looking at revised simplex method of solving linear programming problems. And now revised simplex method is having three main things that we shall need to look at. First of all, we need to understand the objective equation. Then we need to have knowledge of basics and non-basics. So we shall divide our equation and together with the constraints into two parts. That means we shall divide it into a part which is comprising of basics and non-basics. Then we shall represent this in form of matrices. And finally, from this we shall solve for the answer. So, to solve this, I'm going to show you directly through an example how we can solve for this using the so-called revised simplex. I think of all methods that we have, it is one of the hardest methods. But once you have a grasp of this revised simplex method, it will be simpler and it will be the easiest. All the rest will be easy and simple. So with that, let us look at maybe one example and see how this can be resolved. So I'm going to look at an example directly. So here I have an example. So the example says maximize z is equals to 2x1 plus 3x2, which has been subject to x1 plus x2 should be less or equal to 50, and 2x1 plus x2 should be less or equal to 30, and they have told us provided that x1 and x2 are greater or equal to 0. So we have been provided with such an equation and they want us to solve it using the so-called revised simplex method. Now, revised simplex method is so simple in that you're going to write these expressions in form of matrices. For example, you will have a matrix for the main function, which is the objective function. Then you'll have a matrix to represent these constraints. I hope we are together there. That is 50. This one here, it is 50. So, what I was saying is that we are going to divide this equation into two parts. First of all, the objective and the constraints. Then we are going to express the objective and the constraints in terms of two sets, like in terms of matrices. For example, if we are to extract a matrix out of this objective function, first of all, before even you reach the matrix form, we are going to standardize this function here. We are going to standardize it by removing these inequalities. And how do we standardize it? We introduce what we call slack variables. So solution, we are going to standardize that. Shall have z is going to be equals to 2x1 plus 3x2. Now you first leave it there. Then you go to these other ones. It is x1 plus x2. Now to remove this less or equal to, we add a slack variable s1. So plus s1 should be equals to 50. Now we have removed the less or equal to sign. Then we standardize also the second expression, which will give us 2x1 plus x2 plus s2 should be equal to 30. Now these same expressions here that we have here, we are going to take them and feed them into the main function, but while killing them. So for example, s1 here will be plus 0 s1, then s2 will be plus 0 s2. So simply like that, we are finished to standardize that expression. Now after standardizing it, that is what is going to bring us to forming the equations that show us the what? The matrix form of the expression. So for example, this equation up here can be extracted into two parts, that is the coefficients and what we call the variables. So writing a set for the coefficients will be, a set for the coefficients of the upper variable will be coefficients are equal to, now you write them in this form, rho, so that we have the coefficient of x1 is 2, of x2 is 3, of s1 is 0, and for s2 is 0. Then you say the variables x are going to be equals to, the variables we have here are x1, we have x1 being the first variable, we have x2 the second, then we have s1 and s2. Then you say such that when I multiply, I'll have z is going to be equals to c times x1 times x. I hope that can be seen clearly. When I multiply this matrix with this matrix, I'll come up with this expression. Because the reason as to why I'm writing this as a straight one row and this one as a single column is going to be because you have to multiply row by column. You have to multiply 2 times this, which gives us 2x1, plus 3 times this, which is giving us 3x2, plus 0 times s1, which is 0 s1, plus 0 times s2, which is 0 s2. So when you do that multiplication, it simply gets you back to the first objective equation. So you'll have that z is equals to this. So that is what we have done. I hope we are together there. So at that moment, let us also write an expression for these three inequalities that we have here. So for these ones here, the same way, simple, just like what we have done here is what we are going to do for that expression also. So we are going to have them, we shall let a certain set A is going to be equal to these values that we have here, the coefficients of these values that we have. For example, A is going to be equals to, the coefficients of x1 are 1 and 2. The coefficients for x2 are 1 and 1. Then the coefficients for s1 in this first equation, we have 1 because s1 is existing, but in the next we don't have s1. So s1, the coefficient will be 0 because s1 is not there in this lower expression. Then we go to s2. When we reach s2, s2 is existing in the lower expression, so we write a 1 there. But when you go to the upper expression, s2 is not existing, so we put here a 0. Then since we have already generated our set for the variables, we don't need to again write another set for x1, x2, s1 and s2, because you simply realize that what I've done is this here is representing x1, this is representing x2, this is representing s1, and this is s2, like that. So you don't need to again redefine this set for x's, since it is going to look directly like this. Then we go to the values that we get here. So for the values, we shall give them a certain letter b. So we shall say b is going to be equals to their values that we get after summing all these constants. For example, for the first expression we have a 50, and then for the second expression we have a 30. So then you express it such that when I multiply a times x, it will give me the values of b. That's just how you express it. I hope we are together there. If you've not understood here, please ask right away, because where we are going, you may not need to be left behind. Are we together? Yes, someone unmute and say we are together, we proceed. I need your feedback on that. Anyway, since you're not feeding me back, I think you're okay.
We are together.
Okay, thank you. So now let's go to splitting. I said when it reaches the part for splitting, we are going to split this equation into two parts. We are going to have a part for basics and a part for non-basic. Take a charge. So we shall have a part for basic and a part for non-basic. So splitting this into half, I'll have one part here to represent the basic and the other part to represent the non-basic. So for example, the coefficients are going to be divided into two parts. We shall have the coefficients of the basic, this coefficient set C, we shall have CB and we shall have CN to represent coefficients of basic and coefficients of non-basic. So what I was saying is that we shall have two coefficients, that is coefficient of the basic and the coefficient of non-basic. So clearly looking at that, first of all, what do we call basic variables? We know basic variables are those variables with a 1, 1 and the rest in their sets are zeros. So for example, from this set here, you can clearly see that the basic variables are S1 and S2 because they have a single one and the rest of the values in their column are zeros. So these two qualify to be the basics. So after identifying your basics, for example, the values, let me start with the x's. So since I've identified my S1 and S2 are the basics, so I'll have a set for x basic and it will be equals to S1 and S2. Then my non-basic variables are these variables here that are doing what? That don't have a single one and the rest of their members being zeros. So therefore, my x non-basic is going to be these two variables, which is x1 and x2. Now when writing these values of x1 and s2, it is best for you to follow this same nomenclature. The way you've written your x's in that same manner is the same way you write your x basic and x non-basic. In other words, they are following what you've written before. I hope we are together at that point. Then, since we have written our x's, the x basic and x non-basic, let's look at also their coefficients. So for the coefficient of the basic, similarly looking at it, coefficients of basic are going to be equal to, now for coefficient of basic, you look at your main bracket here. The coefficients, the basics are S1 and S2. You look for their corresponding values. Remember that when we wrote this, these first values here were representing x1, this was representing x2, this was representing s1, and this was representing s2. So you come and pick those values from up there. So you go where there is s1, there is a 0 in the C class, so you put there a 0. Where there is S2, there is a 0, so you put there a 0. Then also you do the same for coefficients of non-basic. So the coefficients of the non-basic are going to be, you come here and check. My non-basics are x1 and x2. So I look for x1 in the C set. It is giving me a 2. So I put there a 2. Then I look for x2 in the C set. It is giving me a 3. So I put there a 3. And like that, you've come up with the coefficients of the basic and the coefficients of the non-basic. Then from that, we are going to extract our basics. Our basic set, which is a matrix for the basics, and these basics are going to come from here. This is this set here consisting of our basic variables. Our basic variables are S1 and S2. So this set here is going to comprise what we call the basic set. And then this set here, which is comprising the non-basic sets, is going to give us what we call the non-basic set. I hope we are together there. So, using that same idea, we are going to call, we say the basics are S1 and S2. So, for basic set B is going to be equals to the matrix for the basic. We shall come here and extract this set the way it is. We said S1 and S2 are the basics, so we take S1 is having a 1, a 0, and then S2 is having a 0 and a 1. So we have come up with our set for the basic. Then we look for the set for the non-basic. The non-basic is going to be this set. So you write there, your x1 is 1, 2, and your x2 is 1, 1. Like that. So we have come up with both our basic and non-basic sets. So after coming up with those two variables, I hope people are not writing, or people are writing. So after coming up with those two sets, there is only one last thing you need to do before you start calculating. But remember, these things have marks. So these steps here also comprise of marks. So don't be scared that we are still not working out yet, but there are still marks for solving for those. So at this point where we have reached, we have attained our set of basics and our set for non-basics. Now after achieving that, we are going to do what we call the inverse. The last thing is to get the inverse matrix of the basic set. And when you look at this, how do we get an inverse? The inverse, B inverse, is going to be equals to 1 over adjoint A, 1 over determinant times adjoint. Just simply like that. But the determinant of this set, remember the determinant is given by taking the major diagonal minus the product of the minor diagonal. So we shall multiply this 1 times 1, which is a 1, minus 0 times a 0, which gives us 1 minus 0, which is simply a 1. So this will be a 1. Now the adjoint is going to be, from that B inverse is going to be equals to, now to get the adjoint, you simply swap these two numbers, but since they are identical, even though you swap them, they will still remain the same. Then you multiply a negative to these numbers, but a negative multiplied by 0 still gives us a 0. So these two numbers will remain the same. So therefore our inverse matrix will look something like that. It will not be changed. Now if you're copying, I think I'll give you just a blink of an eye. We finish, then we proceed with that, because where we're going is now the real calculation. And here there are formulas to follow. So, proceeding from there. Yes, Carol, you're saying something?
Hello, how are you?
I'm good.
What if the determinant is not 1 and 1 and it is like 2 and 3, and you have to multiply 2 by 3, so it will be a 1 over 6, is it? Times the adjoint. How do you go about that?
we are going to reach that point. It's just in the next iteration. Just the next thing we are looking at is going to be involving us to get that thing. Determinant won't be 1 over 1. But simply, to put it maybe for the sake of explanation, just in case, suppose on a particular day they provide us with an expression whereby our maybe, hypothetically speaking, our B is going to be equals to maybe 1, 2, let me say 3 and 4, and they want us to get the inverse matrix for this. So to get the inverse matrix for this, we shall be, first of all, get the determinant. Determinant is going to be equals to 1 times 4, which is the major diagonal of this, minus 3 times 2. So when you get this calculating this is going to give me 4 minus a 6. So it's giving me negative 2. Then our adjoint is going to be equals to, you swap these two numbers. So I'm going to get this 4 and take it where there is a 1, and where the 1 will come where the 4 was. Then these two numbers will remain the same. This is 3, this is 2, but I'll multiply them by negative 1, like that. Therefore, from that, I'll divide this whole thing by the determinant. So I'll divide through by negative 2. And my B inverse will be equals to 4 divided by negative 2 will give me a negative 2. Negative 2 divided by negative 2 will give me a 1. Negative 3 divided by negative 2 will give me a 3 over 2. And 1 divided by negative 2 will give me negative a half. So this one here will give me what we call the inverse matrix of that set. I hope that has answered your question, Ban.
Yes.
Okay, so we are proceeding with the question. Here is where we ended. So we ended at this point here, and we had gotten the inverse matrix for that set. So now the first step we are going to take is to calculate for what we call the entering variable, and also we shall calculate for the leaving variable. So step number 1, calculate for entering variable. Now there is something we call an entering variable. The main thing here, the main objective, like as you can see clearly from what we have here, we have a side for basic and a side for non-basic. Our values we want to find, x1 and x2, are in the non-basic side. The values that can be given directly are the basic variables. So what we are going to do is we shall pick a number from here, the non-basic side, and we cross it to the basic side. But we don't know which one of these two we have to take in first. So that's why we are going to first calculate for the entering variable. And after calculating the entering variable, we shall need to know, yes, if at all maybe I've got x2 is the one going to enter first. Then afterwards we shall need to calculate who is it going to substitute in this side, which is what we call the leaving variable. So this is what we are doing here. We want to get of these two values, x1 and x2, which are non-basic, which value is going to enter into the basic side. So with that, let us proceed. So the question there, we are saying to calculate for the entering variable. Now the main point here is we shall use a certain formula. So the formula is simple. It will be, we shall always need to calculate for z we shall need to calculate for zj minus cj, where zj is given by what we call cb b inverse times n j. So what we're simply doing, when I substitute for zj is equals to this in this equation, I'll need to calculate for this value here, cb b inverse nj minus cj. Now here there is only one thing that is going to complicate. This j here, j represents nani basic variable. So to simply put it here, j is going to represent the variables of x1 and x2, which are the nani basics so far in this expression. So when we are substituting them, we shall calculate for x1, then we shall calculate for x2, and then we shall compare to see which of the two is going to enter. So those formulas are like that. We're going to just apply them. They're proven formulas, so we are going to apply them directly. So let us calculate, let me say calculating zj minus cj for x1. So we are going to calculate for x1, and then we shall calculate also for x2. Remember, in maximization problems, we always look for the smaller one. So we shall calculate and see which value is smaller. That value will be the entering variable. So let us calculate for the smaller for x1 first. Now we shall need to keep these two tables behind near us. So let me just keep them here, where we have the basic and the non-basics. So from that point here, we say that zj is the same as, so we are going to calculate for cb b inverse n. Now here, since it is nj, our j is x1, so it will be nx1 minus c, our j is x1, so it will be c x1. So using that same knowledge, we shall go to the columns for, we shall get the cb set, the b inverse set, the n. Now n we shall look for x1, and then we shall look also for c coefficients of x1. So let's do that and see. Substituting for cb from this table, cb is 0 0, so we substitute 0 0. Our b inverse is what we calculated here and got as 1 0 0 1. So we substitute again. So we substitute again for that. Our b inverse, which is 1 0 0 1. Then nx1. Now when it comes to nx1, we shall come to our n set. Now this is our n set. Remember, according to this order, x1 is this is representing x1, and this is representing x2, just according to this order arrangement. What is first here is the first here, what is second here is the second here. So x1 is this, so we shall pick that whole column the way it is and write it there as 1 2 minus our c x2. Now cx1, our coefficient of x1 is this. Remember also here is x1 is this, and this is x2. This is going to be 2, so it will be minus 2. So once you've learned how to come up with that, everything else becomes simple. To multiply this, we are going to take this, multiply it with this, plus this times this. So multiplying 0 times 1 is a 0, plus 0 times 0 is a 0. Then 0 times 0 is 0, plus 0 times 1, which is also a 0. Then we multiply again. We are going to multiply this by 1, 2, and then we shall subtract minus 2 from it. So from that point, 0 times 1 is a 0. 0 plus 0 times 2, which is a 0. So we shall remain with a 0 minus a 2. And 0 minus 2, this is giving us negative 2. So this is the value for x1 is negative 2. Now, let us compute also the one for x2. So we shall say, calculating zj minus cj for x2. So to calculate for x2, simply substitute those values the way it is. Remember, cj is given by, it will be cb, b inverse, n. Now this will be x2 minus c x2. Remember, the order for this doesn't need to change. It has to be cb, b inverse, n. So when you change the order, you'll have changed. You'll remain with something that cannot be multiplied. So let's proceed. Now at that point, substitute. Still, you need to have the table near you. But our CB is not going to change from this. Our CB is equals to a 0. So this will give us a 0, 0, 0. Our B inverse also won't change. It was 1, 0, 0, 1. Sorry about that. Our B inverse also won't change. It is 1, 0, 0, 1. Now when it comes to nx2, you come here to x2 in the n set and you pick the values you have, which is 1, 1. So you write them there in the same order as they are, 1, 1, minus cx2. Our cx2 is going to be the coefficient of x2. So it is a 3. So it will be minus a 3. So from that we shall calculate. Remember, when you multiply 0, 0 by this set here, from what we had got already, it will be have you admitted, Cesar? So when you multiply 0, 0 by this bracket here, 0 times 0, 0 times 1 is a 0, plus 0 times 0, which gives us a 0. 0 times 0 is 0, plus 0 times that, which is also a 0, multiplied by 1, 1, minus a 3. So simply, 0 times that is 0, plus 0 times that, which is a 0. So we shall remain with 0 minus 3, which is going to give us a negative 3. So this is the value for x. This is value for x2, and this is for x1. Now simply what we said from that, we shall choose the entering variable by choosing the smaller one or the more negative of those two. So from that expression you can see clearly that the more negative value of those two values is x2. Therefore you have to conclude and say, therefore x2 is entering. So x2 is entering. So after finding out the entering variable, you need to calculate for the leaving variable. And now, let me put here star and say now calculate for leaving variable. So to calculate for the leaving variable, we are going to use the same technique but this time round the formula is going to be different. So the leaving variable, for it the formula is a little bit different. So I was saying the formula for calculating the leaving variable is going to be a little bit different from that. We are going to use a certain formula whereby we shall calculate for B inverse times B divided by B inverse times NK. Now here, this K here, K is the entering variable. So this K here is representing the entering variable. So where we have now for this particular case, our K, we shall represent it by x2. Therefore for this case, we are going to calculate, we shall calculate B inverse B over B inverse N x2. This will be x2 because x2 is our entering variable. So let us calculate. First of all, calculate for B inverse B. So B inverse B is going to give us our B inverse set. Our inverse set was 1 0 0 1 times our B set. Now our B set, we need to come back to our first equation and get our B set is this. It was a 50 and a 30. So we shall copy that and paste it back again. So it will be B inverse times 30 here. It was what? 50 30. It was 50 50 30 here. So this one, you multiply this, it will be 1 times this, which is a 50, plus 0. 1 times this plus 0 times that. So it will be 50 plus 0 times 30, which is still giving us a 50. Then 0 times 50 plus 1 times 30, which will give us a 30. So from that, we already have our B inverse B set. Now let's calculate also for B inverse. B inverse times N x2. So this is going to give us our B inverse was 1 0 0 1 multiplied by nx2. Now our nx2, from what we had before, our nx2 is this set here of x2 in the n, the x2 set, which is 1 1. So we shall multiply, so times 1 1 here, and it's going to give us, when you multiply that, we are going to have 1 times 1 plus 1 times 1 plus 0 times that, which is giving us a 1. 0 times 1 plus 1 times 1, which is also a 1. So that is the set we have come up with. Now what is left is to divide these two sets. Now to divide them, you'll get this and divide it with this, and also this and divide it with this. So after division, you'll find out that you're going to remain with an upper answer. This 50 divided by 1 was going to give us a 50, and 30 divided by this one here, which is giving me a 30. So this upper value here is going to correspond to the way you had written your S's. So this upper value here is going to represent S1, and this lower value is going to represent S2. Now you choose of those two values and choose which one is smaller. So the smaller value of this is obviously S2. So when you get the smaller value, you can conclude and say, since S2 is the smaller value here, you say therefore S2 is leaving. So you've got your entering variable is x2 and your leaving variable is s2. So using that knowledge, we are going to just swap where there is x2, we shall put there s2. So let me write this on a clean sheet of paper. We said x2 is entering and s2 is leaving. So once you know these two, the entering variable and the leaving variable, you will just need to refer to the first objective or the calculations that you've done, and you see now from this what we have here, where we said the basics. So we need to again. Try to reconnect. Should I disconnect and connect again? What are people saying there? I'm back. Sorry about that. Oh my, what is wrong with this? So I hope you can still hear me. Let me just pin this a moment. So from that, what I was saying is this. So what I was saying is we are going to compare from these two expressions that we have, the basic and the non-basic. And since we know what is entering and what is leaving, we are going to just simply get x2 from here, and we come and put it where x2 is. You getting it? Just direct substitution. Therefore, even these values here, the value for x2 here will come and sit where this one is. Okay? Because this is
Tell the guy to unmute. You can't hear anything.
So what I was saying is you can see clearly from that these tables that we have here, we have the non-basic and the basic side. So what we are going to do is we are simply going to take we said x2 is entering and s2 is leaving. So we shall use direct substitution. Where there is x2, we shall replace it with s2. The value of x2 here, we shall take it and feed it where this value is. Then the sets, this set here is representing s2, and this set here is representing x2. So you will come and also put it there. Is that okay? I know the mark I'm using might be faint, but I intended it so that it doesn't disorganize the work so much. But that is what we are going to do. We are going to take this and put it there. So let us do it here practically and see what I'm talking about. So from that, we have said we have our basic and the non-basic side. So now our new basics, xb, our new one, okay, is going to have the basic values are s1 and x2 now, not so? Then our x non-basic is going to have values of x1 and s2, like that. Then you write also your coefficients. So my coefficients for the basic, substitute still, this is going to come here. So my coefficients for the basic are going to be a 0, and here will be a 3. Then my coefficient for the non-basic are going to be equals to a 2, and the other side we shall have a 0. Then similarly, let's do the same thing for the basic set B. So for the basic set B, it's going to have the following values. This one here is going to remain the same because it is unchanged. It will be remaining 1, 0. So we shall have here a 1, a 0. Now when it comes to this other opposite end, we are going to pick what was here and take it and substitute it there. So we shall pick here, it will be a 1, a 1. Then our non-basic will be, the first row is the same, it remains as 1, 2. Then the next, sorry, this is the first column. Then the next column will be simply replaced by this. So it will be a 0 and a 1. So that is it. We have finished exchanging our values. Now let us get since we have got that, let us get our B inverse. Now our inverse matrix here will be the adjoint. First of all, the adjoint is what determines. So your determinant is going to be this times this minus this times this. So it will be a 1 minus a 0, which is going to give us, the determinant for that will be a 1 minus a 0, which will give us a 1. So the determinant is equals to 1. Remember, our B inverse is going to be equals to 1 out of date times adjoint. So since we have those, let us just do the same. Our B inverse is going to be equals to, now the adjoint for this set is going to be given by what? You swap the positions of these two, which remain unchanged because they are the same. Then you multiply a negative through this. So negative 0 is still a 0. 1 will become a negative 1. And once you've come up with those expressions, you're finished. The next thing is the same step. What we did previously is what we are going to do again. What do I mean? We are going to calculate for the leaving variable, and we shall get also the entering variable. So, but also this step for calculating the leaving and entering variable is used to test. When for a maximized equation, we come up with an expression whereby both sides are okay, where we don't have any negative in that expression after like when we are calculating for the entering variable and we don't get a negative, that is where we stop. But if we are calculating and we get both of them being negative, or any of them being a negative, that value becomes our entering variable. So let us do this and see what I'm talking about. So let us do this computation and see what we are meaning. So for this, to calculate for the entering variable, variable, from this you can simply remember that our entering variables are got by calculating for the value of zj minus cj. So we shall be forced to calculate for zj minus cj. But what is zj minus cj? It is the same as cb, b inverse, n, nj minus cj. So here our j's are going to represent the non-basics, which are, the non-basics are x1 and and the S2. So x1 and the S2 will be our Nani basics. So let's calculate for x1. So let's say calculating for x1. So for x1, it will be equals to CB inverse. It will be, we shall calculate for CB B inverse times N x1 minus C x1 not so. So CB here, now our CB set has changed. You come back and pick it. Our CB set is 0, 3. So here we shall write those values as they are. So it will be 0, 3 times our B inverse. Our B inverse set has also changed. It is this set here, which is 1, negative 1, 0, 1. So we shall have 1, negative 1, 0, 1. Now our nx1, x1 set, remember this here, these values here representing x1, these are representing s2. So our nx1 is this set here, which is 1, 2. So we shall pick that and write it there as 1, 2 minus cx1. Now when it comes to coefficient of x1, go back again. Cx1 is 2. So it will be minus 2. Now let us compute this. So computing for this, you can see clearly that we shall have a 0 times a 1, which is a 0, plus 3 times a 0, that is giving us a 0. Then a 0 times negative 1, which is a 0, plus 3 times 1, which is a 3, multiplied by 1, 2, to give us minus a 2. So this 0 times that is going to give us still a 0, plus 3 times 2. 3 times 2 is giving us a 6. So we shall remain with a 6 minus a 2. So a 6 minus 2 is equals to a 4. Now this alone here indicates that we might have reached the end of our expression because we're having a positive value. Yet we are supposed to get negative values and we compare the more negative one. But still don't stop there. First go and check for S2 also and see if it wants to enter again. So you check for S2. So to check for S2, shall say for S2, shall say it will be, we shall need to calculate for CB times B inverse times N x2 minus C of x2. So putting these two into the equation, now we shall need to come again. B inverse won't change, it will remain the same. So B inverse will be a 0, a 3, times a, this is coefficient of basic, doesn't change from this. We are using the new one, they are the same. So B inverse was also 1, negative 1, 0, 1. Now nx, sorry, I'm using x2. This is supposed to be S2, and also this is S2. So that was a wrong. This is N S2, and this is C S2. So let's look for N of S2. Now go back here. S2 is represented by this here. So it is going to give us our N of S2. So here we shall write N of S2 is a 0 and a 1 minus C of S2. Now coefficient of S2 is a 0. So we put there that 0 again. So from that we shall have 0 times that plus this times that, which gives us a 0. 0 times negative that, which is a 0, plus 3 times 1, which is a 3, multiplied by 0, 1 to give us, and we are subtracting from it a 0. So 0 times this is 0 plus 3 times that is giving us a 3 minus a 0, which is giving us a 3. So from that, someone can see clearly that since both numbers are positive, we don't have any leaving or any entering variable. If you have any one of those being a negative, you know directly the more negative one is the one which is entering. So you take that variable which is negative and you say that that variable is the one which is entering. So you feed it in, you go and calculate for the leaving variable, and then you replace them and you compute. You only stop when you get positive numbers, which means your iterations have ended. What we are doing here, recalculating. What they mean by an iteration is redoing something over and over, repeating the same process, but each time you come up with different values. So that is an iteration. The other one we did was the first iteration. Now we're doing a second iteration. So let us compute for now. Since both of them are positive, so let me write it just for the sake of those doing notes. Since both variables are positive, both values of zj minus cj are positive, we don't have any entering variable. Therefore, we stop there. Therefore, we stop and calculate for the final. We calculate for the final answers. That is, we're going to get the value of x1, x2, and z. Those are the values we need to calculate, because the question wants us to maximize or minimize z, maximize z. That means we need to find the values of x1 and x2, which give us the maximum value of z. So doing that, let us feed those things into the. Now I see time was not on my side, but anyway, let us do this number here. I hope you've understood where we have come from. So let us try to get the final answers. Now, how do we calculate for the value of x1 and x2? Now, to calculate for the values of x1 and x2, the method is simple. So, sorry, I got a little bit caught up with something. But the method is going to be simple. We shall need to get our x basic is going to be equals to b inverse times b. So this is the formula we are going to use. We shall say our x basic, the new one we formed, is going to be equals to b inverse times b. That gives us the values of that. Then to get for z value, now for z value, to calculate for z value, your z value z is going to be equals to coefficients of basic times our x basic new. So that is just how we calculate for those. Those two formulas are what we need to have in mind. So let's try to get the value of x, that is x1 and x2. Now we go to our x basic new. The newest or latest version of x basic we had is this, which is giving us s1, x2. So we shall have s1 and x2 being equals to b inverse. Our b inverse matrix was this, which we have here. which is 1, -1, 0, 1, times our small b set. Now our small b set for that one didn't change. It was 50, 30. I don't have it here, but it was 50, 30. So that is simply it. So we shall calculate for that from that. So multiply through. So here we shall have that S1, X2 set is going to be equals to 1 times 50, which is a 50, plus -1 times the 30, which is 1 times that is 50, plus -1 times 30, which is a -30. Then down here we shall have 0 times this, which is 0, plus 1 times that to give us a 30. So here we shall have a 20 and a 30. So that means that our S1 is equals to 20 and X2 is equals to 30. Now from this clearly, since we don't have X1, any values that are missing here, for example, S2 and the X1, these ones are all going to be equals to 0 because they are missing in this expression. But the values we're interested in are X1 and X2. So we shall simply say X1 is equals to 0 and X2 is equals to 30. So that is it. We have got the values of X and Y. So since we have the values of X1 and X2, we are ready to go. Now let's calculate for the Z value also. I see people are dozing. Okay. But let's calculate for the value of Z also. And then I maybe I invite some few questions. So from that we say that Z is going to be equals to CB times XB new. Now Z is equals to our CB, the coefficient of basic we came up with last is 0, 3. So we shall write here 0, 3 times the coefficient of times X basic. Our X basic new set was S1 and X2. But since we have the values of X1 and X2, we shall substitute. So Z will be equals to 0, 3 into our S1 was, sorry, this was S1, yes, it was 20, and X2 was 30. So multiplying through this, we shall have that our Z is going to be 0 times 20, which is a 0, plus 3 times 30, which gives us a 90. And therefore, this becomes our final answer. So therefore, someone can conclude and say, therefore, Z is equals to 90, and X1 is equals to 0, and X2 is equals to 30. So that is how far we have come. I hope we have come together. We are all on point. I don't believe that right now, if I'm to start Big M, more people will doze off. But that is the slight explanation for that. With this, you can do some few numbers and maybe try to see how it is done. So, do we have any questions so far? Remarks? Sorry, I want some feedback from you people before we call it an evening.
Should we have another example of the same?
Basing on the hour, I don't think. Maybe what I will do is I will try to include it in the next session. But basing on the hour I am seeing people are not at par. And even the time has gone. But we are so sorry about today. There was some delays due to the class lecture, which went beyond the normal timing. We had expected to end early, and so that we start early, but that wasn't possible. But for this, I'll try to make sure at least the next session we have, I'll extend an extra 30 minutes or so to try to cover more ground on this. But as far as this Saturday's test is concerned, I think at least we are there. Unless people demand for some revision on the other two formulas. But what we are left with is the big M, and I think I'll try to squeeze for it before. I think I'll squeeze for it a session on Friday, such that by Saturday when we are doing the test, we shall have more confidence. We shall have sort of a general revision for this. Yes, that is it, I think. But it will be elongated a little bit, so I think that is all. But that was all I wanted to communicate. The session will be a little bit elongated to cater for today's extra hours that we haven't used. Yes. Yes, the past papers, the questions, the trial questions that he gave us. Okay, if we don't have any other remarks, I think let us call it an evening.
Okay, thank you.
Okay, you're welcome.